I'm Alan Holman, curator at the Hampton History Museum. Welcome to our 20th Century Gallery. We're going to talk a little bit more about how the NACA came to Hampton and what happened to it when it began to grow. The NACA founded the Langley Memorial Aeronautics Laboratory here in Hampton on Langley Field, which is operated by the Army. And the purpose of it was to drive forward the technology of aviation. The first engineer in charge, the title now being director, but he was the engineer in charge, was Henry Reed. Mr. Reed, a fine engineer and a fine manager that he was, wanted to keep some measure of control of his growing staff, which in the early days was only a couple of hundred engineers and clerical people. So he had installed on his desk a button from which he could press the button, sirens would sound all over the campus, and people would know that Mr. Reed commanded someone's attention. They could come to him then. Or he would sound the start of the day's work, he would sound the beginning of lunch, the end of lunch, and he would sound the end of the day. And this is the button that was installed on his desk in 1928 that allowed him to do that. As Langley grew and the technology grew, new tools were required to keep moving forward. Wind tunnels sprung up all over Langley's campus. Some were designed for atmospheric flight, really just the speed that aircraft could be flying at the time, 100 miles per hour, maybe 200 miles per hour. They developed a wind tunnel that could be pressurized so that the models they built were flying in similar conditions that they would have found in the open atmosphere. One of the wind tunnels out there was the transonic wind tunnel, and this is a wind tunnel fan blade from that tunnel. This wind tunnel was designed to develop speeds of something in the range of the transonic regime, which would be 600 to 800 miles per hour. So this huge wind tunnel with over 30 blades of this aircraft spruce built 600-pound fan blade turned by a 5,000 horsepower motor could develop such a rapid current of air that it could develop in a small cross-section test chamber air speeds similar to what aircraft were experiencing in the transonic regime, which is a really big problem to overcome. So this was the wind tunnel that really pushed us into the supersonic age. Langley then moved a little bit farther forward and engaged another component of the research, and that is spaceflight. A lot of the spacecraft actually have to be tested in wind tunnels themselves because they do have to come back through the atmosphere and go through the atmosphere into space. But this was occurring in the late 1950s. Again, we found ourselves behind the eight ball a bit. The Russians had launched Sputnik, so there was a great impetus to get moving on things. So Langley shifted a bit in its mission from Langley Memorial Aeronautics Laboratory. In 1958, it was renamed Langley Research Center of the newly formed National Aeronautics and Space Administration. And a lot of the work they did from that point on was to support the space program, including manned space flight, the Mercury, Gemini, and Apollo programs. And by the mid-1970s, a whole new type of space flight was being developed, and Langley, being the bridge between space and atmospheric flight, took a center role in developing the space shuttle. We have here in this case a wind tunnel model made out of billet aluminum to test airfoils for the developing space shuttle, which would then be the most important single component of the space program for more than 20 years. The little holes you can see in the model itself are where they can embed sensors that can read air pressures, so they can test the aerodynamic efficiency of the model and then scale that up to the aerodynamic efficiency of the space shuttle.